Okay.
Alright, so I'm Tanner.
I'm Scott.
Caden. And we decided to do a blender. So this is just all the pictures. We have all the components down there. As you can see, we chose the wrong product because it had way too many parts and it was really annoying. But we did it in the end anyways. So just some functions of it.
The detailed information function is used to mix, puree, or I don't know the word.
Emulsify.
Food and other substances. Stationary blender consists of a blender jar with a rotating metal blade at the bottom, powered by an electric motor in the base. Operating procedure: you click the button depending on what you'd like to do with the food or drink inside. And once the button is clicked, the blade starts moving and the food or drink is done to your specifications. Operating environment: kitchen near a power outlet to plug it in. Cost of blenders range from $50 to $150 depending on where you purchase it. Manufacturing origin: it's assembled and made in Mexico. And the product lifestyle: the product is built and it is placed in a store or online. Someone gets interest in the blender and purchases it, and it's taken home, used until no longer working, then it's thrown away.
So I read on the thing told us what I'll do, and so I did sketches of every single part, and so I have like 17 slides here because, like I said, there's way too many parts. So I'm just gonna kind of flip through them. If you want me to explain them, I will, but it's just drawings of different things. So yeah, there's like 4 screws, so that's always interesting, I guess. Yeah, there's way too many parts here. And there we go. Okay, so now on to all of our tests.
Testing for the screw. The continuity test is 1.694. It's magnetic. It's really hard because it's like dense in its size. The mass is 3.1 grams. The volume is 1 millimeter squared. The density is 1.3 grams. And the surface area, they get that.
What are the numbers on your continuity test?
That was not me. That was those two.
So continuity test, it doesn't do a digital number or something, does it?
A number pops up on a multimeter.
Yeah, it
but
does.
It just makes a sound.
A number does pop up on it?
Yeah.
Huh. Yeah, so if it makes a beep, then that means it conducts electricity, and if it doesn't conduct electricity. That's the continuity test. So it made a beep, right? Did it make a louder beep than some of the other ones because the number's bigger?
Yeah.
Did you get that number off the multimeter?
Yes, I did.
Okay. All right, there's something to investigate later.
So here's all of our inventor parts. We did the fan, we did the large-headed screw, and then we did like the magnet piece on the inside. This was all of our eye properties. So the first one here is the fan. I guess the weight was in pounds, and we did ours in grams, and I forgot to change it to grams, so I don't know if that really lined up. But our area and volume were pretty far off, I believe. I think our volume, like what they calculated, was like 10,000 millimeters cubed or something. And then like the area was something like 10,000. I don't know. They were way off. Our magnet was pretty close. No, it wasn't. Magnet was all of ours were way off apparently. But yeah, I don't know. And these are all the multi-views. They are dimensioned. They're just, they're small pictures, so you can't really see it. That one's really confusing because they all intertwine. Yeah. And then just some of the manufacturing processes of it. The fan, more than likely the fan went through several of the processes. It was probably first put in a die press to get like the rough round shape of it. It does have like a slight raise in the middle of it and then a hole. And then it was probably from there forged to create the individual fan blades, because if you look at it, it looks like each part was just cut and then twisted to make the fan. The screw itself, it was machined to have the right thread count and length, and then magnets most of the time are centered together, so they just kind of get melted together to the right size.
How'd you do the fan and inventor?
So basically what I did is I figured out the rough circular shape of it. I did a measurement of that, and then I made a sketch over here on the outside and basically just extruded out a rectangle to the edge of it. And then I did a circular pattern
Circular
around the
pattern.
entire thing.
Okay.
And then that way they were all the same distance apart and they're all the same size.
Yeah, looks really good.
And then the recyclability of it.
Well, seeing as how the fan was probably made of aluminum, it could be easily recyclable and melted down to create another item, or it could be used as a fan again. The screw would more than likely be very similar to that of the fan, as it could be remelted and poured into a different mold to maybe create new screws for something else entirely. And the magnets used to be harder to recyclable, but now with the advances in
Sintering abilities, but
yep, magnets can be ground down and sintered into new shapes and sizes depending on the requirements of the magnet.
so that was it.
How did you guys measure the volume of the thing?
We used,
Water displacement
yeah, water displacement.
with the graduate cylinders?
Yeah.
So then what were the units for those? Milliliters, right?
Yeah.
And what is that in cubic lengths?
Isn't that like cubic centimeters?
Cubic centimeters,
I got that one
right?
Yeah.
So is that what you wrote the units down as, cubic centimeters? Or?
I think they were in cubic.
Because then the inventor, I think, gives you cubic millimeters,
Yeah.
Yes.
right? So you have to convert to see if you're right there, right?
You'll get
Okay. All right.